In this video, I'm going to show you how to set up the first 5 problems on this worksheet. So before we start, I would point your attention to at the top of the page there, how to calculate probability. It's the ratio, right? It's a fraction. The numerator is the number of ways to get what you want, and the denominator is the total number of possible outcomes or things that could happen. The other thing I would point you to is in the upper right, I put a deck of cards. These are all the cards that are in a standard deck, because all these problems deal with a deck of cards, and you should know what we're talking about, what it looks like. So let's do the first one. Find the probability of drawing a heart. Well, the hearts in the diagram here in the picture on the right, this entire row, those are all hearts. So if you count them up, there's 13 cards, and for each of the suits, you'll see 13. So the probability of drawing a heart, again, the numerator is how many ways you can get what you want. Well, I'll take any heart, and so there's 13 of them, and there's 52 cards in the deck. So the probability of drawing a heart is 13 over 52. And as with all these, you always want to reduce it to lowest terms. So we can divide both of these by 13 and end up with 1/4. So the probability of drawing a heart is 1/4. Number 2, the probability of drawing a heart 7 through 8 on the first draw, replacing it and drawing a queen on the second draw. Okay, so the 7 through 8, all right. Now I'm making 2 draws here, so I'm going to draw a card and then I'm going to draw another card. So that means that I'm going to take the probability of each one individually and I'm going to multiply them together. So here the probability of drawing a 7 or an 8 of hearts. Again, in the hearts, there's only one 7 of hearts and one 8 of hearts. So there's 2 ways the probability of a 7 or an 8 of hearts, that's my heart, is we'll take that and we'll multiply it by the probability of drawing a queen on the second draw. So let's look at these two. The probability of 7 or an 8, again, there's 2 ways to get what I want. A 7 gets me what I want, and an 8 gets me, and there's 52 cards in the deck. Again, we're multiplying these because I want one thing and then I want another. It says here, after we draw that first card, we're going to put it back in the deck. So that means I'm going to have 52 cards again when I go to make the second draw. And the second draw, I want a queen. I'll take any queen. Well, this whole column right here, in the upper right here, you can see those are all queens. So there's 4 queens in the deck. So 4 out of 52. And I can just multiply these two together, right? We multiply straight across. The 2 times the 4 and the 52 times 52. And I'll leave you to multiply those and see if you can reduce them. Number 3, the probability of drawing a black card on the first draw, replacing it and drawing a black card on the second draw. Well, the black cards, if we look, this whole row right here, those are the clubs. Those are all black, and this row right here, those are spades. They're all black. So there's 13 in each suit. So that means there's 13 ways. 13 times 2. There's 26 ways for me to get a black card, and there's 52 cards in the deck. I want one thing and then another, so I'm going to multiply them. Again, I put the card back after I do the first one, so I'm going to have 52 cards to choose from the second time. And again, I want to draw a black card, so that's going to be the same probability as the first, and I'll leave the multiplication to you. Number 4, find the probability of drawing a black 7 through 9 on the first draw, replacing it, and then a red card on the second draw. A black 7 through 9, right? Well, a 7 through 9, there's a black 7 of clubs, spades, 7 or 8 and 9 of spades, and a 7, 8, and 9 of clubs. So there's 6 ways to get what I want, and there's the 52 cards in the deck. Times, again, I'm putting that card back after I draw it, so in the second draw, I'll have 52 to choose from, and I want a red card. So red card can mean any of the hearts or any of the diamonds. Again, 2 suits there, so there's going to be 13 26 red cards. It'd be 13 diamonds and 13 hearts. So 26. Sorry about that. And then there were leave it to you. If I were you, I'd try to reduce some of these fractions before I did the multiplication. It'll make all the numbers easier. All right, last one. Find the probability of drawing an ace of diamonds on the first draw, replacing it, and then a diamond card on the second. Well, the ace of diamonds in a legal deck, there's only one ace of diamonds in the deck out of 52 cards. The second time, again, I'm putting the card back, so I'm going to have 52 to choose from. A diamond card, right? We said there's 13 in each suit, 13 spades, 13 clubs, 13 hearts, and 13 diamonds. So that means there's 13 ways to get what I want, to get a diamond. And as is the procedure here, I'm going to leave you to do the multiplication. Again, I would try to reduce that 13 over 52 before I did the multiplication. Best of luck with the multiplication, and done.